Matrix multiplication tends to be the hardest operation, so really pay attention to this one because once we move on to some of the other methods for solving a system, this particular skill is going to come in super duper handy. So matrix multiplication. First of all, it's important to understand you can't just multiply any two matrices together. Because of the way that we multiply matrices, we need the number of columns in our first matrix, I'm calling that matrix A, to be equal to the number of rows in the second matrix. So if I'm taking A, which is a 3 by 2 matrix, and B, which is a 2 by 4 matrix, notice the 2 and the 2 match up, and that's what tells me, yes, I can multiply them. In addition, the resulting matrix will be a 3 by 4. Notice then, if I look at multiplying them in the opposite order, this is a 2 by 4, this is a 3 by 2. These guys aren't the same, and therefore I cannot multiply B times A. I can only multiply A times B. Now on the next slide, I'm going to actually work through one or more of these with my pen, but I wanted to give you sort of a clean slate without all my chicken scratch all over it. I mean, I'm going to write all over it, don't worry. But this is essentially the steps that you would go through. And so what I'm going to do is I'm trying to multiply the rows of the first column or the first matrix by the columns of the second matrix. So I think of it like this. I'm thinking of, oops, gotta go back to my pen. I'm thinking of these as rows, and I'm thinking of these as columns. So here's how it works. My first row of -1, 3, I'm kind of thinking of taking it and going like this and turning it into -1, 3. And then what I do is I take it times 5 and times 6 and times -3 and times 8. So I want you to notice if I took -1 times 5 and 3 times 6, notice that's what I have here. So this result, my first result, is my first row times, oops, my first row times my first column. And then I take my first row times my second column, -1 times 3, 3 times 8. That's where this came from. And my first row is done now because I've taken my first row times each column. Then I would move on to the next row. The next row is 3, 5, so I would think about it the same way. 3, 5, I kind of shift them around so that they're orientated correctly. I'm going to take it times 5, 6, and -3, 8. So 3 times 5 plus 5 times 6, that's my first element in the second row. And then times my second column, 3 times -3 plus 5 times 8. That's where that second one came from. And then obviously you can see the pattern. I'm taking my last guy, 0, 1, and I'm multiplying it by 5, 6, and -3, 8. So 0 times 5 plus 1 times 6, and then 0 times -3 plus 1 times 8. Then all I've done is just reduce. So I took -1 times 5 and 3 times 6, and then I added them together to get 13. So the rest of it's just simplification, and that's how I got my final answer. So hopefully that last line makes perfect sense because it's really me just simplifying the math. This guy in the middle, this is the hardest part, is for you to come up with what's being added. Now in terms of work that you need to show, I either want to see this matrix or this matrix just so that I can see the work that you did. So obviously this will be your original problem. I want to see either one of these two things and then of course I want to see your final solution. So if you want to show both of those steps, you can, but you don't have to for my benefit. If you want to for yours, you can, but I want to see one of the two of these. So either this that shows what you multiplied, or this that shows what you ended up adding together. So let's do one together. First of all, we have to make sure that we actually can multiply them. So this guy is a 3 by 3, and this guy is a 3 by 2. Because my 3's match up, I can multiply them, and my answer is going to be a 3 by 2. So 3 rows, 2 columns. Whoops, usually I leave myself a little bit more room than that. 3 rows, 2 columns. So this is typically how I do it by hand to leave myself room, and then I'm going to start multiplying it. So as you can see, I've left a little bit more room. I'm going to take 1, 2, 3 and write it this way instead. So this is going to be 1 times negative 6, and I'm just going to show that second matrix. So 1 times negative 6 is negative 6, plus 2 times negative 3 is negative 6, plus 3 times 1 is 3. My second space on my first row would be 1 times 5, which is 5, plus 2 times 4, which is 8, plus 3 times negative 2, which is negative 6. And then I'm going to take a different row, 4, 5, 6. I like to turn it into a column, sort of, so it makes it easier to multiply. 4 times negative 6, negative 24, plus 5 times negative 3, negative 15, plus 6 times 1, which is 6. 4 times 5, which is 20, plus 5 times 4, which is 20, plus 6 times negative 2, which is negative 12. Then I erase all of that, and I get a new row. And my last row is 7, 8, 9. So 7 times negative 6, plus 8 times negative 3, plus 9 times 1. Next column, 7 times 5, plus 8 times 4, plus 9 times negative 2. And then of course my final answer, I'm just going to add all of those things together. Feel free to do mental math or use your calculator. It doesn't matter to me. And again, you can write these things underneath if you want to. It really doesn't matter to me. You don't have to, but it still should be a 3 by 2. If I combine negative 6 and 3, I get negative 9. 5 plus 8 plus negative 6 is 7. Down to my second row, negative 24 plus negative 15 plus 6 is negative 33. 20 plus negative 12 is 28. And on to the next row, negative 42 plus negative 24 plus 9 is negative 57. And 35 plus 32 plus negative 18 is 49. So that is my final answer. Let's look at another. This one says find a squared. And so what I find a lot of students do is they'll say a squared, and then they'll just try to square 4 to get 16, and 1 to get 1, and negative 3 to get 9, and 0 to get 0. And that is absolutely not true. Remember, just like if I told you x plus 1 quantity squared, you would have to FOIL it out, which we've done so much in this class. It's the same idea here. I have to take 4, negative 3, 1, 0 times that again. So again, I should check, and just to save you the drama, whenever you have a square matrix, you can always square it and you can multiply it. Square being that it's 2 by 2 or 3 by 3 or 4 by 4. It can always be multiplied with another square matrix that is the same size, 2 by 2, 3 by 3, 4 by 4. So I'm going to have an answer that is a 2 by 2 matrix, And again, this one I'm thinking rows, this one I'm thinking columns. So I'm going to take my first row, and I'm going to say 4 times 4 is 16. And again, you can draw your little lines to help you remember. 16 plus negative 3, and 4 plus 0. And then I erase that and do my next row. Negative 3, 0 would be negative 12 plus 0, and negative 3 plus 0. So my final answer, 16 plus negative 3 is 13. 4 plus 0 is 4. Negative 12 plus 0, and negative 3 plus 0. And that's my final answer. Here are several for you to try, so press pause, try all 3 questions, then press play to see how you did. First thing I'm going to do for each one is always to see if I can actually multiply them. A is 2 by 2, B is 2 by 3, so I can multiply them, and I'm going to end up with a 2 by 3 matrix. So let's go ahead and do that one. 2, negative 5, 1, 0. And then 3, 6, 5, 0, 4, negative 8. To multiply these, remember I'm taking rows times columns. I should have a 2 by 3 matrix. Hopefully I can fit all of that on one line. We'll see how I do. I better start writing smaller. So 2, negative 5 goes here. So 2 times 3 is 6 plus negative 30. To my second column, 2 times 5 is 10. 5 times 0 is 0. And my third column, 2 times 4 is 8. And negative 5 times negative 8 is positive 40. Then I take my other row, which is 1, 0, and multiply. 1 times 3 is 3 plus 0. 1 times 5 is 5 plus 0. And 1 times 4 is 4 plus 0. So my final answer for my first one is 6 plus negative 30. So negative 24, 10, 48, and then 3, 5, 4. Sorry I had to write so small at the end. I got a little space greedy before. B times C, can I do it? B is 2 rows by 3 columns. C is 3 rows by 1 column. Those guys match up, so we can do it, and I get a 2 by 1 matrix as a solution. So B is 3, 6, 5, 0, 4, negative 8 times 106. My answer is going to be 2 by 1. So I shouldn't run out of room on this guy. So let's get cracking. I'm going to take 3, 5, 4. I'm going to rewrite that 0 in the middle of this guy because I couldn't even tell what it was. So 3 times 1 is 3, plus 5 times 0 is 0, plus 4 times 6 is 24. Then I'm going to take my second row and do the same thing. 6, 0, negative 8. 6 times 1 is 6. 0 times 0, negative 8 times 6, negative 48. Final answer, 3 plus 24 is 27. 6 plus negative 48 is negative 42. And last guy, A times C. A is 2 by 2. C is 3 by 1. These guys don't match up, so that is not possible.